To the new episode. So, in our last session, we explained how to implement deep first search traversal algorithm using stack. However, there is an easier approach to do this deep first search, and that is the recursive approach. So, in a new lesson, you will study recursion in details, but right now, just to implement these methods here, these algorithms, you should know 2 points about recursion. So, first, what does recursion mean? Recursion means calling a method inside itself. For example, here you have this DFS. If you call this DFS method inside this method itself, that means recursion. So, and you should know 2 points about recursion. One is the base case, one is the recursive case. Because if you don't know these 2 points, there is a possibility of falling into an endless recursion, and that will end up in stack overflow. So, the base case is the case that you stop your recursion, and the recursive case is the situation that you keep calling the method inside itself. So, and when you use recursion, when you have a problem, and then when you start solving that, it happens that you divide that problem into smaller problems, and then start solving them. However, if you come across any problem that when you divide a problem into smaller ones, the smaller ones look the same as the main problem but at a smaller size, that is when you call recursive method, recursive approach. And let's consider this example, this tree, traversing this tree. If it was a large tree, or if you consider this one as a large one, so you change it to small trees, to small sub-trees. And each tree has like a root, left child, and a right child. Let's say, for example, we have one tree here, and if you change this to one tree, and you have this and one tree, again, you see that all of them have the same structure, and we follow the same approach. So that is better that you develop one method and call it inside itself as far as you come to the last small problem. So, here with recursive approach, there are 3 different approaches that you can do that recursively, and that means that, for example, when you come to at the very last problem, at the very last tree, so you have a root node, you have a right, left, and you have a right node. So, and the point is that we have to visit all the nodes in this tree. So when you are at the very last sub-tree, so you can check them pre-order. Pre-order, that means first check the root, then the left, and then the right. Pre-order. In order, so that's like an in order. You start from left, root, right. And post-order, it is like somehow against pre-order. First you check the left and right. After that, you check the root. So, now let's write a method for this, how we implement these 3 different approaches recursively. Public void, so DFS, it is pre-order. Let's pass the node, mostly it is the root node. So, always check your base case, that when you need to stop calling recursively, you should not fall into a loop, endless loop. So you say if, for example, once you come at a point where there is no other branch, for example, when you start checking from here and come here and here, so at this point there is no next node. So when you reach this point, when the node comes to a point that it points to null, that means you have reached the very end of the tree and you need to return that. Otherwise, you at the very small tree, you have three approach, and now we are using the pre-order. In pre-order, first we check the root, we make any comparison or we check its data, and then move to the left and then to the right. But here we only print them. So first print the root node. So we say system.out.print node.data, and let's make a space between them like this. So first print the root, then call this method on the left child. So DFS pre-order node.left, and after that call it on the right one, DFS underscore pre-order node.right. It is how you implement the depth first search using recursive approach. Here you don't have a stack to visit all of them, but you visited every node recursively. So let's test this and see, like, does it really visit every node or not? For the moment, if the recursion is a bit unclear to you, don't worry, we will explain it in a very detailed separate lesson. But for the moment, you should know that the recursion means calling a function inside itself, and you are doing that when you divide your problem into a smaller one, and your smaller problems looks exactly the same as the main problem but at a smaller size. So that's when you keep calling the method inside itself so that it can go to the very smallest problem and start solving the problems. So come to the main class. So here say tree.dfs pre-order, pass the root okay, tree.root. Before that you can print a label also, like here we have DFS BFS, so you can say system.out.print, and here you can say DFS pre-order. Actually, before that, go to the new line and then so now let's run this and see what happens. Okay, here you can see the DFS, and it has printed all the nodes. But see how it has printed. First it checked 50, then 30, because we called the left, we are doing this pre-order. That means first we check the root, then the left, then the right. So it has checked 50, then it's left 30, and when you are here, so you go to left again 15, and then from here you keep backtracking. So you check 50, 10, and then you come to this one, 20 and 8 and 5 at the end. So let me say print ln, so that should be printing in a new line like this. So it was pre-order. See how simple it is. Here, in using the stack, we had to write this much code, but here we just called the same method 2 times. That's it. So now let's do the in order one. Public void DFS in order. So pass the root node here. So first, always check the base case, so that if you have come to the end, you have to stop recursion. If node equals null, return. Otherwise, so in order, for example, when you are at the very last subtree, in order, first you print the, first you check the left, root, right. So first call the DFS on the left method. You say DFS underscore in order node dot left. Then check the root. So you say DFS underscore system dot out. We are just checking here, and by checking I mean there we don't have any extra operation. We are not like looking for any specific node, so we just print that. Print, and that is node dot data. Node dot data. And so left, root, node, right, DFS underscore in order node dot right. That's it. That's how you implement the in order approach. So now let's call this one and see how it looks like. DFS in order. DFS in order. See, DFS in order. First it printed 15 because we said with the in order we start from the left node, then the root node, then the right node. So first it printed 15, then the root to this sub-branch is 30, and then the right one 10. So this part finished, then you come to this part. So generally you start from the very last left and keep checking to the right. So it was how you did the in order, and there is the post order approach. Post order is somehow against this pre-order. For example, in pre-order, first you check the root, then you go to the left and right. But with post order, first you check the left and right, then the root. So public void DFS underscore post order, pass the root node. So check the base case and say if node equals null, return. Otherwise, so in the post order, first check the left, then the right, then the root. So DFS underscore post order node dot left, first left, then right, DFS underscore post order node dot right, and now you check the root. And by checking the root, I mean making your comparison. But now here you only print it. So we say system.out.print node.data plus something like this. So now let's check them. Okay, DFS post order. Okay, you see the post order now. First it printed 15, then number 10 because we said left, right, then the root 30, and then number 8, then number 5, then number 20, and then number 50. So using all these three approaches, you can visit every node in the tree, and you can use any of them that you like. But now generally, like, you know, 4 different easy approach to use DFS and visit every node in the tree. So when you use a stack, you are writing like a regular method, and then considering the stack, you can keep track of all the visited nodes. But if you use the recursive approach, then you have 3 different ways to do it recursively. So again, I emphasize on reading recursion separately. We will explain that, but for the context of this lesson, you should know that you are calling a method inside itself, and there you do that considering 2 situations. One is the base case, when to stop the recursion, and one is the recursive, when to call recursively. So I hope it was clear enough that you know how to implement DFS. Until the next lesson, have a nice time.